Let us see examples of inclined plane in frictions here. So we are seeing this first problem, but we are starting with the basics still. A particle of weight 40 newtons. Now whenever you hear the word weight, you don't need to multiply with the gravity because weight is all we need. So a particle of weight 40, so this one is nothing, 40 newtons. Rests on the rough plane inclined at 40 degrees to the horizontal, and it's just about slide. So if it's just about slide, it means it's going to go downwards. So meaning our friction force will be upwards. Find the value of coefficient of friction between the plane and the particle. So now we are going to be having a horizontal, normal reaction, R, and then if we have resolved this, because we have this already, so this one is going to give us 40 cos 30 degrees, and then this will give us 40 sine 30 degrees. Now, because the body is going downwards, it's about sliding. So meaning for us, the frictional force is going to be in this direction like that. That's why we are going to have our frictional force. So after that, I think the rest are okay. So this is our 30 degrees, this one here. So the basic how we resolve that. Okay, so after that being that, find the value of the coefficient of friction. Now, if we have resolved along the plane like this, so we have there something. Along the plane, we don't have anything like acceleration. So acceleration is going to be zero, meaning along the, upwards, this is in equilibrium, meaning R is equal to this. So our R is equal to 40 cos 30 degrees. And you can see that will be 40 into cos 30 is root 3 over 2, which will be our R becomes 20 root 3 newtons. Okay, now when I resolve, now let us resolve along the plane. So resolving along the plane, now we are resolving along the plane like this. Because the body is about slide, so this force is just not moving. So it's not moving, so acceleration is zero, meaning this force is balancing with this force. So there, so at our F. Okay. If we say it's not moving, you can say our F, then minus the 40 sine 30 degrees is equal to the mass, and then the acceleration, because it's about to move. So that's why we say the acceleration is going to this also, the acceleration times the mass, we get zero. All we are doing, we are putting this equation. The resultant force is equal to mass times the acceleration, but here our acceleration is zero because the body is about slide, so it's not yet moving. That's why we say the resultant force here, the force which is pulling it in that direction is this minus this equal to zero. And remember, this one is mu R equal to, when I take this side, equal to 40 sine 30 degrees. But our mu is what we are looking for. Our R is 20 root 3 equal to 40 into a half. So our mu is going to be, this is going to give us 20 over 20 root 3. Yes, after simplifying that, our mu is going to be 1 over root 3, which would be 0.5774. We don't have units there, and so we've got it there. These are very easy questions to handle, please. Okay, a body of mass to reference lies on a rough plane inclined at this. So we are saying this one is inclined at a certain angle theta, then it's of mass. See down here, this one is mass. So whenever it's mass, to get weight, to get the mass times the gravity. So that's why we are having to give. Of course, because it's there, we are going to have a reaction like that. Okay, so I've read the basic. So, anyway, we continue. A force of 20 newtons is applied to the body parallel to and up the plane. Parallel and up the plane. So this is going to be our body. Our force of 20, is it 20? 20 newtons. Up and up the body and up the plane. If the body accelerates, up the plane at, so now we are going to accelerate our body, we are going to have a certain acceleration. So it's going to be in that order, acceleration. So we have an acceleration in that order. So if you are going up, always friction is opposite to the acceleration. So I think you know that. Okay. So the acceleration is given there. Find the coefficient of friction between the body and the plane. So after that, we first resolve this. Now, anyway, this one is going to be 2d cos theta, and then this one is going to be 2d sin theta. Now remember, we are going to be having a friction force. Because this is moving up, it's always opposite the direction of acceleration. So there I think we are through. By now we did theta. So that our theta is equal to sine inverse of 12 over 13. So meaning here our sine theta is equal to 12 over 13. So from there immediately you draw a right angle triangle and you get the other side. I think you can see it's already 5. Anyway, it goes to our opposite is 12. This is 13 hypotenuse if we base on this. So this is opposite over hypotenuse. So you see this is 13, 12, this will be a 5. Those 5 numbers there. So when you do that, now we can easily get cos theta. So implying from there, our cos theta is going to be adjacent over hypotenuse. Okay. So now if we have resolved this body, if we have resolved like this, always remember our resultant force is equal to MA. But along, parallel to the plane, ornament to the plane, there's no acceleration. That's why we say that always our R minus 2d cos theta is equal to 0. So our R will be equal to 2d, then cos, which is going to be 5 over 13. So our R is going to be 10d over 13. Basically. Because you don't have, whenever you don't have anything there, the force is okay, it's just acting around the plane, the rest are very easy. So, after having this, we're going to use this in the second step there. Now we resolve, because the acceleration is in that direction, we base on the acceleration of the particle. So it's in that direction, now resolve in that direction there. So that acceleration, remember, our resultant force is going to be equal to the mass times the acceleration. So our resultant, according to this, what is pulling this to go there is the 20 first. So the 20, and the opposite, yes, we have this, so minus 2d sine theta, then also F minus F, the frictional force. Because this body is moving up, friction is going to act downwards, equal to the mass, which is 2 times acceleration. Our acceleration was given as what? Our acceleration was given as 1.5. 1.5. I think that's going to be 3. Okay, so this will give us 20 minus g into, now sine theta is 12 over 13, then minus f. What is Rf? Our Rf is mu R equal to 3. So we have our R. So when we take this side, we have 20 minus 24 g over 13. Then will be minus mu over R, which is 10 over 13. It will be equal to 3. Now, if I bring this side and I take this side, you see I'll be having 20 minus 3, then minus 24g over 13 equal to, when I take this side, I have now mu into 13g, 10g over 13. From there, what happens? We just multiply through by 13. So you see here we have 17 minus 24g over 13 equaling to 10g mu over 13. So if you multiply through by 13, multiply through by 13. So here by 13, we have 1 minus 24g equaling to 10g mu. And then the rest, if we substitute there, we shall have our mu as 221 minus 24 into 9.8, and all over 10 into 9.8. And so our mu there is going to be okay, 9.8 minus 221 divided by 98. So here I'm getting negative 0.1449. Now, why do you think this is negative? Can you give me a reason why you think that is negative? You look here. So after seeing that it's negative, what comes into your mind? Anyway, the moment you start it's negative, it implies that the body was retarding. So that's the implication of that. So don't scare when you get it. Anyway, there is another explanation which you are going to see in the next example about these negatives. So that's it, members. See you in the next lesson.